Hello, my name is Johan Pedersen. I come from the company Ignion, where I'm in charge of business development. And I'm extremely excited to be here today with the Things Network and with the big conference. And thank you all for joining. I'm going to talk a little bit about the importance of antenna design in your IoT devices, in your trackers. And we at Ignion have a unique virtual antenna technology that really makes your product design easy. And I'm going to tell you a little bit about why that is so important. At Ignion, we are reshaping the world's IoT connectivity by making it super simple. We are a global innovator with a proven track record, powering more than 25 million devices already in the field, with more than 1,500 OEMs worldwide. And we have a team with more than 20 years of experience in the antenna industry. And our mission is to accelerate your innovation, accelerate your time to market by making the antenna designs of your devices super easy, regardless of which frequency you're using, regardless of what wireless technology you're using. We have a very unique virtual antenna technology that enables you to use one SKU for any wireless technology for any frequency, just by having simple tuning and leveraging our wireless virtual antenna components, and then you're off to the races. So how does our virtual antennas technology impact your time to market, and how does it make your designs easier? When we are in the context of logistics and tracker designs, a key thing that our antennas influence and solve for you is having a more efficient RF path, which means less burden on the energy budget. As most IoT devices today are battery powered, particularly in the tracker segment, the efficiency of the antenna has an impact of how much power you need to emit through the wireless module, and thus on the battery life. So if you have a 3 dB loss because of a poor antenna design, it will impact your battery life and your maintenance of your tracker. And I here outline that you have the LoRa module, and then in the RF path you maybe have peripherals, switches, LNAs, and then the antenna. And that RF path, the more simple you make that, the less loss you will have, the less cost. And this is where our virtual antenna technology really shines, by making it easy and making it super efficient. By using virtual antenna technologies, you can really optimize your battery life in your IoT devices. So let's take a look at what we mean by that. Here we have a simulation of antenna efficiency and battery life. So you see here 3 dB and the impact 3 dB has on the years of battery. So we have the years here on the y-axis and the output power on the x-axis. And you can see that just 3 dBs actually have several years of impact. And actually it corresponds for the radio power 3 times more energy. Or if you have 2 times 3 dB, 6 dB, it is closer to 6 times more power that you need to achieve the same. Overall, antenna efficiency and battery life go hand in hand. And when it comes to LoRa, when you want to go further out, you need to crank up the power on your module, and also to reach those further distances, lowering the data rate. And by having a very efficient antenna, you can ensure to have not only longer battery life, but also higher throughput of data on the antenna. So how does that look in practice? We have made some physical measurements of a LoRa system that also has GNSS and Wi-Fi on the same system. We are here using a virtual antenna component, which enables you to have all three in the same device. All three with one component, which is quite unique and quite amazing. And what I'm showing here is the impact of the PCB size on the antenna efficiency. So if you look at this graph, we have the antenna efficiency versus the frequency. So here you have sub-gigahertz, here we have GNSS, and then we have Wi-Fi. And if we look at the sub-gigahertz, the LoRa example, for the highest one here, we have a board size of 125 times 50, which almost reaches 80% efficiency. That is a very efficient antenna. But if you reduce the board size down to maybe 54 times 50, you are in the 40s of efficiency, meaning that the PCB size has a significant impact on the RF performance. 40% might be fine, and you can go with a smaller design, but if you really want to have that higher efficiency, it's important to take into consideration the size of the PCB. And we have documented all of this as in a collaboration with Semtech, and you can see that in this white paper that we are linking to here. And just a few other comments, as obviously having one component controlling all three technologies here is quite amazing. But you might already be familiar or might already be using FPC antenna technology or PCB traces. And I just want to highlight that when you're using FPCs or when you're considering them, it's important to know that when you're using them in the lab, you might have them lying next to your PCB design, and then you have decent performance. Then when you close it in the box of your tracker, then you will see a very different performance. It's very dependent on the placement inside the device. So it's quite risky in terms of the antenna efficiency, whereas with the virtual antenna technology, there's no risk because you know already before what efficiency you will have, and you will be able to adjust it and tune it. So there's no surprises. And also with regards to PCB trace, this is a very cheap technology. However, it does have the downside of being not flexible at all. You have to make a new design every time you change something. Whereas the virtual antenna technology is extremely flexible. And whenever you're making an adjustment, you can just tune the virtual antenna and keep the same component and the same design. When you are placing a tracker on a cow or on a container, the ambient environment does play into the connection, obviously. And I'm highlighting two important parameters here that we are talking about, and then where the virtual antenna technology really helps you, making it easy. So one is radiation, and the other is distance to other materials for the antenna. So when we talk about radiation, whether your device is how your device is oriented, might if it doesn't have a omnidirectional radiation pattern, it might not be able to see all the satellites that it needs to in order to locate the device. But with the virtual antenna components, you have an omnidirectional pattern, which ensures that you will always have the minimum connections needed to have the right location of your device. And regarding distance to other materials, I've here highlighted an example of GNSS and Wi-Fi and its impact of how the distance to a piece of metal. And here you can see that going from 5 mm distance to 20 mm distance, we see a significant higher efficiency when it comes to having longer distance to the metal. And this is where this generic node design has 20 mm distance and has a great performance with the virtual antenna. So radiation pattern is important and distance to other materials. And the cool thing about virtual antennas, before you make it in practice, you can simulate this and ensure that your device meets the needs before you actually build it. And that is very important because not every device or no device is equal. They are all unique. Containers are not the same as pallets or cows. So it's super important and super helpful to be able to simulate what will happen and to plan your design and be able to choose what antenna efficient do you want to achieve. By leveraging our simulations, we have a lot of services around that where we can easily simulate your specific product in your specific context and help you eliminate the risks of not having an optimal design of your RF path on your antenna. And the virtual antenna technology enables you to adjust. If you have changes to your design, you can easily adjust it by just changing the matching circuit. If you're changing the device size, if you want another protocol at another frequency, you can use the same component and just adjust it to that particular use. And as I mentioned before, our technology is multi-radio, multi-band, so you can use one SKU for several wireless technologies in the same product, which is quite fantastic. And today in the tracker world, there's very few that are using only one technology. So typically multiple antennas are required, but here you only need one antenna. So I invite you to come and try out our portfolio of virtual antenna components. We have 6 to cover everything, and each of them can actually cover a very large frequency range, but we do have a few differences depending on how many bands, how many technologies you would like in the same device, and how high efficiency you will want versus cost. So if you want the best performance and 3 technologies, 3 wireless technologies with one antenna, you will go for the trio. But if you just have one wireless technology you want to cover and efficiency is not your priority, you are more focused on cost, then you will go with our nano. I invite you to scan this QR code and experience our wireless fast track service, where you can get introduced to our antennas in the context of your application and your device. We only need to know the frequency that you're operating in and the size of your PCB. We don't need to know much more. And then we can send you a report with suggested antenna part, and then we can simulate the performance of your device and help you get fast to market with your next IoT project. We are super excited to be a part of the Things Network and the Things Industries. And we have a lot of awesome partners that we collaborate with. And we want to invite you to join the revolution. As Vinke here from TTI, he says is there, that we really appreciate the collaboration. And if you are a design house or a module manufacturer or even an operator and carrier, we are looking to partner up with you to help make IoT development easier. We're already working with a lot of partners, and we really believe that collaboration is the way to go to really reach the full potential of IoT. So with that, I want to thank you for your time. And if you have any questions, please reach out on our email address here. And I also list here a few of our global offices. And then enjoy the rest of the conference, and see you soon.